Hello everybody, Unit 4, Day 5. If you're watching this, you either didn't take notes during class, in which case shame on you, or you happen to be quarantined, and for that I apologize. Okay, so either way, thank you for joining us. Okay, I like getting this, I like to see lots and lots of views on these guys, so yeah, all right, appreciate it. So anyway, what are we doing, right? Throughout this unit, or throughout these next couple lessons, we're going to be going between radical form and exponential form, okay? And so remember, earlier when I mentioned a couple times, the square root of x is really just x to the 1/2 power. And so we're going to be kind of switching in between these guys, in between having rational exponents or radical form in order to simplify expressions. Okay, so again, no equations in this. We're just simplifying expressions. Okay, and what's an expression? It's just something like, well, not these because these are numbers, but something like this, right? We don't know what x is, so therefore it's left as an expression because it could be anything, right? So anyway, continuing on that, all right, what is a rational number, all right? Well, it's important to know what a rational number is. It is any number that can be expressed as a fraction, okay? Any number that can be expressed as a fraction. So 2/3, rational. 2, oh, slap a 1 under there, rational, okay? 55 over 87, okay? Rational, all right? So anyway, any number that can be represented as a fraction, okay? So like numbers like 0.333333, right? Still a rational number. What is that number? 1/3, okay? So all these things still apply for rational numbers, right? So anyway, what was that? Sorry. Sending an email. All right. Anyway, let's get started. What are we looking at? Well, it's telling us just to simplify, right? So when you're taking the square root of something, right, really what we're looking at is what times what equals 16, okay? So in this case, the answer is 4, right? So the square root of 16 is just 4. How about here? We're looking for the cube root, right? So what times what is equal to 8? When there's only one number for that, and that is a 2, right? How about this guy over here? What number times what number times what number is equal to a negative 27? Okay, well, the answer is negative 3. All right, and you're probably thinking, well, wait a second. That's a negative underneath the radical. Okay, we'll get to that part, but generally speaking, okay, the only time you get imaginary numbers is when your I don't know how you want to say it, your index, right? This number right here. In this case, this is your index. This is your index. Your index here is 2, right? Even though we don't see it there, it's assumed, right? Our index is 2. But every time you have a odd index, okay, you can have negative numbers in there, right? Because negative 3 times negative 3 times negative 3 is negative 27, right? So anytime you have an even one, though, an even index, that's when you get those imaginary numbers, all right? And we'll keep practicing these as we go, all right? And then this last one, what number times what number times what is equal to 16? Again, that's just a 2, okay? So the only time you get those imaginary numbers is when your index, this number right here, okay, is odd, all right? So anyway, taking a look down here, right? So this is how we change it, right? Your index, all right, is always your denominator, right? And so when you have a number like this, x to the, I don't know, the 3/2, right? This number right here, your denominator, will always go on the outside. And then your numerator, your a value here, will always go on the inside. Okay? And so that is what that looks like. Now again, all right, sometimes they'll be mean and they'll just leave this 2 off. Okay, so anytime you see something like this, right, this is still the same thing, all right, except that sometimes they're, mathematicians are lazy and we leave it up to assumption, right? If you don't see anything here, then we can assume that's a 2, right? So any other time, right, if this was a 4 or a 7 or whatever, you would see that there, okay? However, all right, if you don't see anything here like this, all right, we assume it's a 2. But until you get more comfortable with that, maybe write that 2 in there just to sort of remind yourself of what that is. Because I see a couple examples down here, right? This one right here, even though we don't see it, our index is just a 2, right? Which kind of makes sense because, we don't see it there again, there's there's a 1 next to that A, right? Anything raised to the first power is just that number, right? And so following our method, right, A, right, the 1 would go on the top and the 2 goes in the denominator. Okay, so even for our most simplest radical, this rule still works. Okay, so if you're wondering how I came up with that 1/2, okay, look no further, right? There's a 1 next to that A, kind of like when there's a 1 in front of the X, right? It's there. We don't have to write it, but it is a 1 times an X. Okay, so in this case, that 1/2 comes from that A having an exponent of a 1. So we put that in the numerator, and whatever is on the outside is in the denominator. So following that method, then this guy, it's got a 1 right there, right? So this guy is going to be a to the 1/3 power, right? Then we move over, all right? I put the number that's on the inside here in the numerator, and the guy on the outside, the index, is the denominator, okay? And again, we didn't see it here, so we assume it's a 2. So this one's going to be a to the 3/2 power, okay? And that's how you want to think about going in between radical to rational exponent. Now again, we're just rewriting with a rational exponent. Okay, we could simplify these if we wanted to, but we're not gonna. Okay, so this guy here, this is just negative 125 raised to the 1/3 power, which if we were to simplify this, okay, this would be just a negative 5, right? Because what times what times what equals a negative 125? Negative 5. Okay? How about this guy? This would be negative 2 times 16 raised to the 1/4 power. Okay? So that's also can be simplified, right? This guy right here is what times what times what times what is equal to 16. Well, if you recall, that was a 2. So 16 to the 1/4 power is just negative 2 times 2, which would be a negative 4. Okay, so even though it's not telling us to simplifying it, I'm doing it anyway, okay, just so you guys can see the process. And finally, this guy here, this is a negative. We're taking the cube root of 27, and so what times what times what equals 27? Well, that is a 3, and so our answer is just a negative 3. Okay? But again, you got to get comfortable with getting to this step first, okay? Which is rewriting it with a rational exponent, okay? Let's take a look at number 3. Number 3, rewrite the expression using positive rational exponents. Okay, even though we don't see it there, we know that that's a 2. So this is x to the 1/2. This is x to the 1/3. This is x to the 2/3. Okay? Now, this is where it gets a little tricky. Okay? So, 27, starting with this guy, raised to the 1/3. All right, the next we have this x squared. So this is x squared over 3. This is y to the 6 over 3. And this is z to the 1st over 3. Again, all of them are, their exponents are over 3, right? And then I just sort of adjusted whatever exponent they had on the inside. So 27 just had a 1 here, z just had a 1, and the other ones had 2s and 6s. But we can simplify this, right? Because we know what 27 to the 1/3 power is. That's just a 3. And then this guy right here, well, 6 divided by 3, that's just a 2. And there it is simplified. All right, and then finally over here, this is going to be y times z raised to the 6 over 11 power. Let's take a look at example 4. Example 4. Okay, now we're rewriting it in radical notation, so we're going the other direction, right? And so here, we'll start with my x. 4 goes on the outside, 3 goes on the inside. Boom. Okay, how about letter B? Letter B, okay, let me rewrite this so you don't mess this up. This is x to the 1/2 times 5. Okay, so if this was in parentheses, like we see down here, okay, we would raise both the 5 and the x to that 1/2 power, but it's only the x being affected. So this is just 5 to the square root of x. Whoops. Okay, how about the guy down below here? All right, so this 5x is being raised to this 1 over t power. So put the 1 on the inside, t goes on the outside, and if you don't like that 1 there, go ahead and take it off. But I'm going to leave it there just for learning purposes. Okay, and then finally, negative exponent, right? So what do we got to think immediately? We got to think that this guy does not belong where it's at, right? It belongs in the denominator. So let's take this guy, put him in the denominator, and then raise him to that power. Okay, so that's our first step, all right? Negative exponent, put him in the denominator, all right? Now, let's adjust this so that we're, following what we're supposed to do here. So I'm going to put the xz, I'm going to raise that to the 4th, and we're going to take the d root of that, right? I guess that's how you would say it, right? Because we don't know what d is. But if we did, and we knew what x and z was, we could certainly find those. Okay. All right, example 5. All right, gets a little tricky here. Okay, so I'll try to take this as slow as I can, and just follow along the best you can. Okay, so this guy, we're taking the square root, right? So we have a 2 here. Okay, so what we're doing is this. Remember when we were taking the square root of stuff like 48, right? We were looking for pairs, right? So 2 and 24, 2 and 12, 2 and 6, 2 and 3, right? Boom, boom, boom. Hockey stick, couple choices. So this is going to be 4, square root 3, right? So same sort of pattern here, except we're just writing out how many A's and B's we have. So how many A's do I have? Well, I have 3. So how many pairs do I have? Well, I only have 1, so I bring out an A gets left behind. Now, let's take a look at the B's. Now, I'm going to write all these B's out. Okay, there's 20 B's. So let's pick out the pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 B's with none left over. So our answer is just this guy right here. Okay? Now eventually what I'd like you to do is to sort of utilize this index, okay, and just sort of divide into those exponents, right? How many times does 2 go into 3? Well, it goes in once, right? So that'd be 1A with a remainder of what? Well, 2 goes into 3 once with a remainder of 1. So 1A stays behind. And finally with the B's, right? 2 goes into 20 how many times? 10 with a remainder of 0, so no B's get left behind. Okay? So anyway, hopefully we'll get to that sort of level, but for now we can stick with this method. Works fine. Okay? So right here, we're doing the 4th root of all this stuff, right? So let's take a look at 25, right? I can't think of a number that would multiply by itself 4 times to get 25. So 25 is hanging out, all right? Sorry, bud, you're stuck behind. All right, so next one, let's take a look at the A's. So I have 3 A's, all right? So in this one, right, we're looking for pairs of 2, okay? And this one, our index is telling us we're looking for pairs of 4. So if we look at our A's here, how many pairs of 4 do we have here? Well, we don't have any. And so guess what? A gets left behind. How about the B's? All right, I have 4 B's. How many pairs of 4 do I have? Fun. So I bring a B out. And how many got left behind? None. And then finally C's. So I got 1, 2, 3, 4, 5, 6, 7. How many pairs of 4? 1. So take a C out, leave 3 behind. Okay? And again, how many times does 4 go into 4? Once, with a remainder of none. How many times does 4 go into 7? Once, with a remainder of 3. And that's what we got left behind. Okay, this guy here. All right? We're still going to use prime factorization for these, and I kind of encourage the hockey stick method, even though I'd like to try to get away from that in the future. I think for now, with these particular problems, it's pretty sound, okay? So this is going to be 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Nothing but 2s. Okay, so see... Ooh, now we're looking for crap. We're not looking for pairs of 2. Okay, we're looking for pairs of 3. So let's circle our pairs of 3. 1 and 2. So I have 2 pairs, or, 2 sets of 2 there. So I'm going to bring out 2 times 2, which would be 4. And then let's see what else we can bring out here. Oops, I'm writing over on the other side. So that's the only negative part about the hockey stick method, is it does take up lots of space here. Okay, so let me just see if I can make that go a little smaller. There we go. All right, and so now let's take a look at our x's, right? How many pairs of 3 do I have in there? None, right? So let me rewrite this here. So we got 4, 3 square root. So we got a 2 left behind, and we got 2x squareds left behind, right? Because we can't take a pair of 3 out of 2, right? So this guy's done. Let's take a look at the y's, right? Well, we have 6. 1, 2, 3, 4, 5, 6. How many pairs of 2 do we have? Or, I'm sorry, 3. Yo. Oop, oop, oop. Try that again. Boom, boom. Okay, because we're looking at the index here, sorry. So we're going pairs of 3. Right, so how many pairs of 3 do we have? 2. So I bring out a y squared. And no y's get left behind, right? Because we used them all up. And finally, our z's. Okay, how many pairs of 3's do we have here? 1. So I bring a z out, leave 1 behind. And there's our answer. Okay, and finally, this last one. All right, easiest method for this would be to first multiply that 2 to all of these exponents, okay? So let's go ahead and do that. So we're going to have negative 8 raised to the 2/3 power. We're going to have x squared raised to the 2/3 power. And then we got y to the 4th raised to the 2/3 power. So, what do? Well, this guy right here is going to be a, what is that, negative 4, or, yeah, right, that's going to be 4. Okay, you can just plug that in your calculator. This guy, we're going to multiply through, this is going to be x to the 4/3 power, and this is going to be y to the 8/3 power. Okay, and so now, all right, we got to figure out what we can bring out and what can be left behind, okay? So eventually I'd like you guys to utilize this trick, but for now, let's just write this how we have it here. So this is going to be x to the 4/3, and this is going to be y to the 8/3, okay? So, whoops, wrote that backwards. Okay, so how many x's can I bring out of this guy here? Well, we have 4, right? 1, 2, 3, 4. How many pairs of 3 do we have? Just one. So we're going to have 4x with 1 left behind. And then this guy here, we're going to have a y, 8 of them, right? Okay, how many pairs of 3? 2. So I'm going to bring out, whoops, 2 y's. And how many get left back? 2. Oops. Times 3 square root 2. And because we have the same radical, I'm going to bring those together. And so our answer is 4x y squared times the cube root of xy squared. Okay? And a little trick for that is think of it like this. Okay? How many times does 3 go into 4? 1 time with a remainder of 1x. How many times does 3 go into 8? 2 times. So we bring out 2 y's. What do we have left for a remainder? Well, we would have 2. And so y squared stays inside the parenthesis, or the radical. Okay? So this last part, right? We are doing examples without a calculator. Okay? So not entirely important, right? Because you're going to always have a calculator to do these problems. But I'll go through them rather quickly, and you could either utilize the trick or not. That's up to you. Okay? So here's how I do it. Take this number right here, right? This number, or what number squared is equal to 9? Okay, well that's going to be 3. And then take a look at this guy. So we take this number and we raise it to whatever that power is in the numerator. And so this answer is 27. Okay? Let's try the next one. Negative exponent. Shove them in the denominator, raise them to that power. Okay? So now we got to figure out a way to simplify 32 raised to the 2/5. So what raised to the 5th power is equal to 32? Well, that answer is 2. So then you take that number, 2 squared equals 4. So our answer is 1/4. Try it again. Okay, negative 32 raised to the 1/5 power. I don't know why I'm rewriting that. Okay, so what number raised to the 5th power is equal to a negative 32? Well, don't think too hard. It's negative 2, right? Because we just did that over here, right? What power equals 32? Well, that's 2 to the 5th. So if we wanted a negative one, right? Well, we just make that negative. And anytime you multiply, or anytime you raise a negative exponent to an odd number, it always stays negative. Okay? And so negative 2 raised to the 5th power is equal to negative 32. So then we take that negative, or that number, raise it to that numerator power. And so our answer is just negative 2. Let's come down here. All right, I see a negative exponent. I'm going to shove that guy in the denominator, raise him to that power. Now, what number times itself 3 times equals 64? Okay, so what times what times what equals 64? Well, that's 4. And then we take that number and we raise it to whatever that numerator is. So our answer is not 16, but 1/16. About this guy right here. 16 raised to the 1/4. Now technically, we can find that out, right? 16 raised to the 1/4, well, that's just a 2. And then 2 squared, well, that's just a 4. Okay? Or maybe you didn't think about it like that. Maybe you had 16 raised to the 1/4 squared. So you multiply that too. So 16 raised to the 2/4, which we could simplify that to 16 over 1/2. And the square root of 16 is 4. Finally, last problem. Okay, negative exponent. And so kind of like over here, right? Anytime you see something raised to a negative exponent, we shove them in the denominator. All right, this guy, anytime you see something like this, it actually gets flipped up to the numerator, right? So this one's actually going to be 64 raised to the 2/3 power. And again, 64 raised to the 2/3 power is just 16. Okay? So anyway, hopefully this helps. Good luck, you guys. And any questions, make sure to ask them.